Hello guys, welcome back to the Civil Engineering YouTube channel. Please subscribe our channel for daily civil engineering videos. Today our lecture is about the flexural stiffness. So in this lecture, we will be solving one problem to find the flexural stiffness of the beam. So this is the problem given to us, and this is the figure of this beam. The problem states that a cantilever beam having length of 10 foot, you can see the length of this cantilever beam is 10 foot and loaded 100 kips at the free end. So the 100 kips load is acting at the free end of the beam, and find the flexural stiffness of the beam if the elasticity of material is 29,000. So we want to find the flexural stiffness of this beam when the elasticity is 29,000 and the cross-section detail of this beam is 10 inches and 12 inches. This is the rectangular type of beam, cantilever beam, having the load acting on the free end. So to solve this problem, a solution will be like that. For the flexural stiffness, we know that for the cantilever beam, in the load acts at the end of the beam. So the formula is for the flexural stiffness. The flexural stiffness can be found out at 3EI divided by L cube. This is the formula we know from the literature, that if the beam is the cantilever beam and it is the axially load and it is flexural loaded at the end of the beam, free end of the beam, so we can use this formula to find the flexural stiffness. Right? Every type of beam has different formula, and every different type of the loading condition has the different flexural stiffness. So I have to put the values in this formula from this beam, so to find the flexural stiffness of this cantilever beam having the load at the free ends. Now the 3 is the constant, E is the elasticity of the material, which is given to us 29,000. The E is known to us, which is 29,000 ksi. And the moment of inertia, we will find the moment of inertia of this beam. So moment of inertia of this rectangular beam can be found out by this formula, BH cubed by 12, where B is the 10 inches and height of this depth of this beam is 12 inches. So 12 into cube divided by 12. So by calculating, I get my value of moment of inertia comes out to be 1440 inch 4, right? Inch power 4. So this is the moment of inertia. I can write it here. Moment of inertia we found for this beam, inch power 4, and the length of this beam is not known to us. So sorry, the length of the beam is known to us, which is 10 foot. So the length of the beam is also 10 foot, but we have to convert this into inches. So I will multiply it with the 12, because 1 foot is 12 inches, so it comes out to be 120 inches. Now I will put all this value in this formula, so I will find the flexural stiffness of this beam. So 3 into elasticity is 29,000 and moment of inertia is 1440, while the length of this beam is 120 inches, right? And cube, right? So now by solving this formula, by calculating these values, so I get my answer of 72.5 kips per inches, right? This is the flexural stiffness of this beam. It means that the 72.5 kilo-pound force is required to produce a unit displacement in this beam. To find a unit displacement, like it changes of unit displacement, right? 1 inches. For 1 inches displacement of this beam, it requires the force of 72,000 pound, or we can say 72 kilo-pound force is required to produce a unit displacement in this beam. So this was the topic about the flexural stiffness, how to find the flexural stiffness of a special type of beam, the cantilever beam having the load at the free end of the beam. This formula is valid only for the load acts on the free end of the cantilever beam. For the different scenario of the beam loading conditions, we have different flexural stiffness formula, so you will use the other formulas to find the flexural stiffness of the other types of the beam. Hope you guys understand, and don't forget to subscribe my channel for daily civil engineering videos. Thank you for watching our video.